Hello, Maurits here. This is a short video about a particular type of problem that first can be seen as hard, but actually is fairly easy. So say we have this question. Let x be a random variable in a binomial distribution, n, 1/6. So p is 1/6. The probability for success is 1/6, and n is unknown. Find the value of n such that the probability that x is larger than 0, in other words, that we get at least one success, is larger than 0.9. And if you read a question like this and try to understand what it means, it might sound a bit hard, but let us put this in some context. So one possible way to get this distribution is to rephrase it like this. A fair die is thrown over again. How many times would you need to throw it to have at least 90% chance of getting at least 1/6? We can see that the probability for success is 1/6. In other words, the probability to get a 6. And to have at least 1/6 is that x, that is the number of 6's, should be larger than 0. And that should be 0.9 or 90%. But an easy way to think about this problem is to say, what is the probability to not get a 6 at all? That is 10%. And how could we throw the die to not get a 6? And if we have that the probability that x is larger than 0 should be larger than 0.9, that is another way to say that the probability that x equals to 0 should be less than or equal to 0.1. And to not get a 6, the probability for that is 5 out of 6. So in other words, what we want to find here is 5 out of 6 to the power of n, that is the number of trials, should be less than or equal to 0.1. What is the first number that will make this true? And we can solve this using logarithms. We can also solve this by graphing. So we'll start with the graphing method. So I go into menu here, I go to graph mode, and I enter 5 divided by 6, and then to the power of x, we must call it x here, right? And the other one is 0.1, and then we draw it. And initially, by the way, you probably have the initial setting like this, right? So we won't see the intersection here. So I will go in here and set Windows and X max to some bigger value, say 20, to see if we get some intersection. And draw. And maybe we have one over there. So it's gsolve, intersect. We find here x must be 12 or n must be larger than or equal to 12.6. In other words, n must be equal to 13. And to verify this, we can check by going into the ordinary run mode. 5 divided by 6 to the power of 12 should be larger than 0.1, and it is. And 5 divided by 6 to the power of 13 should be less than 0.1, and it is. So that is the correct answer. We could also have solved this using logarithms. So we have this equation again here. And actually what we will do is we want to solve this equation. So we start with taking log base 10 on both sides. Let us call that LG. So, okay, LG 5 over 6 to the power of n should be equal to LG of 0.1. We know from one of the logarithms rule that we can move this one in front. So n LG 5 over 6 and LG of 0.1. What do you need to take 10 to the power to get 0.1? That is minus 1, right? And then we divide by LG 5 over 6. So we get that n equals to minus 1 divided by LG 5 over 6. So let's try that on the calculator. Minus 1 divided by log 5 over 6. And we'll get the same thing we got before, 12.6 something. And for this 5 over 6 to the power of n to be less than 0.1, n must, in other words, be 13. And we can try that again. Two different ways to solve the same problem. I hope this helps a bit. Thank you.